I am Basir-Ahamed-Khan, Department of Physics, Krishnath College. Today, the first lecture is the first lecture of Module 6 on Special Theory of Relativity. Today, I mainly discuss few topics on Special Theory of Relativity. These topics are inertial frame, the definition of inertial frame, then the fundamental postulates of Special Theory of Relativity, then Lorentz transformation and inverse Lorentz transformation. Next is relativity of simultaneity and the order of events, and lastly today I will talk on the topic length contraction. The first of all is the inertial frame. What is inertial frame? Now the inertial frame, the definition of inertial frame, the coordinate system in which Newton's laws of motion are valid is called inertial frame. That means the coordinate system in which Newton's laws of motion are valid is called inertial frame. This is called inertial frame. Now second one is the postulates of special theory of relativity, fundamental postulates of special theory of relativity. Now Einstein's special theory of relativity are valid for inertial systems only. This theory is based on the following postulates. First one is that all the fundamental physical laws have same mathematical form in all inertial systems. All fundamental physical laws have same mathematical form in all inertial systems. And second one is the speed of light is constant and independent with the motion of the source and observer, and no signal can be transmitted with a speed greater than the speed of light. This is the second postulate. That means there are two postulates. One is all the fundamental physical laws have same mathematical form in all inertial systems, and second one is the speed of light is constant and independent with the motion of the source and observer. Now the Lorentz transformation. Let us consider two inertial frame S and S dash. In S frame the coordinates are x, y, z. O is the origin, and in S dash frame the coordinates are x dash, y dash, z dash, and O dash is the origin. S dash frame is moving with velocity v with respect to S frame. Then the equation of transformation, now from S to S dash are x equal to x dash equal to x minus vt by root over of 1 minus v square by c square, y dash equal to y, z dash equal to z, and t dash equal to t minus vx by c square root over of 1 minus v square by c square. These equations are Lorentz transformation equation. These four equations are Lorentz transformation equation. These equations are transformation from S to S dash frame. Now if we consider these transformation equation from S dash to S, then this equation becomes x equal to x prime minus of minus v t prime divided by 1 minus v square by c square, that is x equal to x dash plus vt dash root over of divided by root over of 1 minus v square by c square, y equal to y dash and z equal to z dash. And lastly the time t equal to t prime minus of minus v x dash by c square divided by 1 minus v square, that is t equal to t dash plus vx dash by c square divided by root over of 1 minus v square by c square. These are inverse Lorentz transformation equation. These are inverse Lorentz transformation equation. And in the previous page, these equations are Lorentz transformation equation. Lorentz transformation equation, and these are the inverse Lorentz transformation equation. Now, relativity of simultaneity. Suppose two events occur in S frame at position x1 and x2 and time t1 and t2 in S frame. And suppose in S dash frame these two events occurs with time t1 prime and t2 prime respectively. That means two events which are occurred in S frame at position x1 x2 and time t1 t2 in S frame, but we consider in S dash frame the time of occurrence of these two events be t1 prime and t2 prime respectively. Then t1 prime equal to t1 minus vx1 by c square divided by 1 minus v square by c square, and t2 prime equal to t2 minus vx2 by c square divided by 1 minus v square by c square. t1 prime and t2 prime are the time of two events occurring in the S dash frame. Now if I consider these two events occurs in S frame at the same time means occurs simultaneously. Two events at position x1 and x2 in S frame occur simultaneously. Simultaneously means in S frame t1 equal to t2. So from equation 1, if although t1 and t2 is the same, but since x1 and x2 are different, then t1 prime not equal to t2 prime. Therefore, this means that the events now which are simultaneous in S frame are not simultaneous in S dash frame. That is, simultaneity is relative. Now, the next topic is order of events. Here, we consider two events occurring in S frame at time t1 and t2 and at points x1 and x2 respectively. Here also I consider two events occurring in S frame at time t1 and t2 and at points x1 and x2 respectively. Let the second event follows the first event. Let the second event follows the first event, that is t2 greater than t1. Now t1 and prime and t2 prime are the same, here it will are the are the same T1 prime and T2 prime are the same at the time of occurrence of the same events in S dash frame. Then T1 prime equal to T1 minus Vx1 by c square root over 1 minus v square by c square, and T2 equal to T2 prime minus Vx2 by c square root over 1 minus v square by c square. So if order of the events written in S dash frame, then T2 prime minus T1 prime should be greater than 0. Please notice that if I have considered two events occurring at position x1 and x2 at time t1 and t2 in S frame, and I assume the second event follows the first event in S frame, that is t2 greater than t1. Now if t1 prime and t2 prime are the times of occurrence of the same events in S dash frame, then T1 prime equal to this and T2 prime equal to this. Suppose this is equation 1. This is equation 1. Then if the order of the events written in the same in S dash frame, then T2 prime minus T1 prime should be 0. That is, I put these values from equation 1 and we get this minus this equal to greater than 0. That is T2 prime T2 minus T1 greater than V by C square into x2 minus x1. Then x2 minus x1 divided by T2 minus T1 less equal to C square by V. This will be true as long as x2 minus x1 divided by T2 minus T1 less equal to C. That means this is the nothing but the velocity. This is the velocity. So this velocity, the value of this velocity is less than c. Therefore, we conclude that order of events will remain unchanged if no signal can be transmitted with a speed greater than the speed of light. So, if the order of the events remain same in S dash frame also, then it is okay. But if this order will be changed only if the velocity velocity x2 minus x1 divided by t2 minus t1 is greater than c. Otherwise, the order of the events will be the same in all reference frame. Next point is the length contraction. Suppose two reference frame S and S dash frame is moving with velocity, uniform velocity v with respect to S, and a rod is placed in S frame with its length parallel to x axis. S frame with its length S dash frame with its length parallel to x dash axis. The length of the rod in S dash frame equal to L0 equal to x2 prime minus x1 prime, and this is the proper length. The length measured by an observer staying in the S dash frame equal to L0. That means x2 prime minus x1 prime, and x2 prime and x2 prime is the coordinates of the two endpoints. If x1 and x2 are the coordinates of the endpoints of the rod measured by an observer in S frame, then the relative length L equal to relative or apparent length L equal to x2 minus x1. This is equation 2. Now I use this Lorentz transformation x prime equal to x minus vt 1 minus v square by c square in equation 2. Then L0 equal to, in equation 1, L0 equal to x2 prime minus x1 prime. I put these values of x2 prime and x1 prime and I get this term x2 minus x1 divided by 1 minus v square by c square equal to L divided by 1 minus v square by c square. 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 Therefore, L equal to L0 times root over of 1 minus v square by c square. Now, since v less than c, therefore root over of 1 minus v square by c square less than 1. So L always less than L0. S always less than L0. Thus, length of the moving rod always shorter than its proper length. Now, special case is if V equal to C, then from equation 3 you see that L equal to L0 root over 1 minus v square by c square, V equal to C, that means within the root 1 minus 1 equal to 0, that means L equal to 0. Thus, if V equal to C, then L equal to 0. That is, its length would be 0, which implies that no object can have speed equal to speed of light in vacuum. It is very interesting. If V equal to C, then length of the rod would become 0, which implies no object can have speed equal to the speed of light in vacuum. So this is the first lecture of module 6.